So here we have the function f of sine 2t minus 3 times cosine of 2t. So we need to find the Laplace transform of the given function. So Laplace transform of 5 sine 2t minus 3 times cosine of 2t will be equals to, so here we are going to apply the linearity of Laplace transform. That means we can apply the Laplace transform to each of the two terms separately. So we have Laplace transform of 5 times sine 2t minus the Laplace transform of 3 times cosine 2t. Now 5 is a constant, we can pull it out of the operator. So we have 5 times the Laplace transform of sine 2t minus, similarly, 3 times the Laplace transform of cosine of 2t. So 5 times Laplace transform of the sine function is it's 2 over s squared plus 2 squared minus 3 times the Laplace transform of cosine of 2t will be s divided by s squared plus 2 squared. So we have 5 times 2, which is 10, divided by s squared plus 4 minus 3s divided by s squared plus 4. Or we can simply combine the two fractions as the denominator is the same. So we have 10 minus 3s divided by s squared plus 4, and of course the value of s must be greater than 0. So this is the Laplace transform of the given function. Now let us do another problem. So here we have the function 3 times cube root of t plus 4 times e raised to the power of 2t. So let's find out the Laplace transform of the given function. So we have 3 times cube root of t. Cube root of t can be written as t raised to the power of 1/3 plus 4 times e raised to the power of 2t. Now using the linearity property of the Laplace transform, so we have Laplace transform of 3 times t raised to the power of 1/3 plus Laplace transform of 4 times e raised to the power of 2t. Now we can pull out the constants out of the operator. So we have to find the Laplace transform of cube root of 3 plus 4 times the Laplace transform of e raised to the power of 2t. So which will be equals to 3 multiplied to Laplace transform of t raised to the power of 1/3 will be, so here we are going to use the formula. Laplace transform of t raised to the power of p is simply equals to gamma p plus 1 divided by s raised to the power of p plus 1. So we have t, it's gamma 1/3 plus 1 divided by s raised to the power of 1/3 plus 1 plus 4 times Laplace transform of the exponential function e raised to the power of at is given by 1 over s minus a. So here a is 2, so we have 1 over s minus 2. So that will be equals to 3 times. So we know that gamma p plus 1 is equals to p times gamma p. So we have 3 multiplied to 1/3 of gamma 1/3 divided by s raised to the power of 1/3 plus 1 is going to be 4/3 plus 4 divided by s minus 2. So the 3 and 3 gets cancelled, and that leaves us with gamma 1 over 3 divided by s raised to the power of 4/3 plus 4 divided by s minus 2, and of course s must be greater than 2. Let's move on to the next question. So here we have the function f of t equals to 4 times e raised to the power 2/3 of t. So let's find out the Laplace transform of the given function. So we have Laplace transform of 4 times e raised to the power of 2/3 of t. will be equals to, so 4 being a constant, we can pull it out of the operator. So we have 4 times the Laplace transform of e raised to the power 2/3 of t. So we're going to use the definition that Laplace transform of e raised to the power of at is simply equals to 1 over s minus a, where s is greater than a. So we have 1 over s minus 2/3. So a here is 2/3. So that gives us 1 over 3 over 3s minus 2. So 4 times 3 is 12. So we have 12 divided by 3s minus 2. And 3s minus 2 must be greater than 0. Or we can simply say s must be greater than 2/3. So this is the Laplace transform of the given function. Let's move on to the next question. So here we have the function f of t equals e raised to the power of 3t minus e raised to the power of negative 3t whole squared. So we need to find the Laplace transform of this given function. So there are 2 ways of finding the Laplace transform. So let's begin with the first method. So in the first method, what we're going to do, we're going to simply expand the given function because it's an identity, a minus b whole squared. So we have e raised to the power of 3t whole squared plus e raised to the power of negative 3t whole squared minus 2 times e raised to the power of 3t times e raised to the power of negative 3t. So that gives us e raised to the power of 3t times 2 will be 6t plus e raised to the power of negative 3t times 2 will be negative 6t minus 2 times e raised to the power of 3t. So we can add the exponents. So we have 3t minus 3t. So that will be 0 and that the entire exponent will be equals to 1. Meaning, so we'll be left with e raised to the power of 6t plus e raised to the power of negative 6t minus 2. So this is the expansion of the given function. So we have f of t. Now we'll determine the Laplace transform of the given function f of t. So that will be equals to Laplace transform of the entire function. So we applied the property of linearity. So we have Laplace transform of e raised to the power of 6t plus Laplace transform of e raised to the power of negative 6t minus, so 2 being a constant, so we have we're going to take it out of the operator, so that will be negative 2 times the Laplace transform of 1. So Laplace transform of 6t will be 1 over s minus 6 plus Laplace transform of e raised to the power of negative 6t will be 1 over s minus of negative 6 minus 2 times the Laplace transform of 1 is 1 over s. So that gives us 1 over s minus 6 plus 1 over s plus 6 minus 2 over s. So we can combine the first 2 terms, so that will be s minus 6 multiplied to s plus 6 in the denominator, and in the numerator we have s plus 6 plus s minus 6 minus of 2 over s. So the 6 and negative 6 gets cancelled, leaving us with 2s over s minus 6. So s minus 6 plus 6, s minus 6 times s plus 6, so that will be s squared minus 6 squared minus 2 over s. So we have 2s divided by s squared minus 36 minus 2 over s, which will be equals to s multiplied to s squared minus 36. So we have 2s squared minus 2 times s squared minus 36, so that will be 2s squared plus 36 times 2, which is 72. So the 2s squared and negative 2s gets cancelled, leaving us with 72 divided by s times s squared minus 36. Of course, s must be greater than s squared minus 36 must be greater than 0. So we said s squared is greater than 36. I can say s must be greater than the modulus of 6. So this is the Laplace transform of a given function. Now let's try method number 2. So what we're going to do here is we are going to multiply and divide by 2. So we have 2 times e raised to the power of 3t minus e raised to the power of negative 3t divided by 2 whole squared. That's done because this is simply 2 times the sine hyperbolic function of 3t. So we have 2 squared, which is 4, and sine hyperbolic squared 3t. Now we know that cos or the hyperbolic cosine function of 2x is equals to 1 plus 2 times sine hyperbolic squared x. So if we rearranged it, so that gives us sine hyperbolic squared x is equals to cosine of cosine hyperbolic 2x minus 1 whole divided by 2. So we have sine hyperbolic 3t whole squared, so that will give us 4 times cos hyperbolic. So we're 2 times 3t, so that will be 6t minus 1 divided by 2. So we can have 2 times cos hyperbolic 6t minus 2. Now we're going to find out the Laplace transform of this particular function. So Laplace transform of 2 times the cosine hyperbolic 6t minus 2 is equals to 2 times the Laplace transform of cosine hyperbolic 6t minus 2 times the Laplace transform of 1, which is equals to 2 times Laplace transform of cosine of 6t is s divided by s squared minus 6 squared minus 2 times Laplace transform of 1 is 1 over s. So we have 2s divided by s squared minus 36 minus 2 over s. So we're solving like combining the two fractions. So we have s times s squared minus 36, and the numerator we have 2s squared minus 2s squared plus 72. So that gives us 72 divided by s times s squared minus 36. So this is the second way, or the second method of determining the Laplace transform of the function f of t equals e raised to the power of 3t minus e raised to the power of negative 3t whole squared. So here we have the function e raised to the power of at minus 1 divided by a. So let's find out the Laplace transform of this particular function. So we have 1 over a. So 1 over a is a constant, so we have taken it out of the Laplace transform. So we have 1 over a times Laplace transform of e raised to the power of at minus 1, using the property of linearity of the Laplace transform. So we have Laplace transform of e raised to the power of at minus Laplace transform of 1. As per definition, Laplace transform of e raised to the power of at will be 1 over s minus a minus Laplace transform of 1, which is 1 over s. So that gives us 1 over a multiplied to s times s minus a. So we have s minus of s minus a. So that gives us a in the numerator divided by a times s minus a. So the a and a gets cancelled, and we have the Laplace transform of s times s minus a, and of course s must be greater than a. So this is the Laplace transform of the given function.